this is looking at transformations of polynomial functions. This is the general form of the equation, and this exponent up here could be anything. It could be a 2, a 3, a 5, a 756. It all behaves in the same way. So let's have a look at what the negatives, the b's, the a's, the h's and the k's, what do they actually do and what do they mean? So this negative here out the front represents a reflection across the x-axis. This a value is a vertical stretch or compression. This negative here in front of the b is a reflection across the y-axis. This b value here is a horizontal stretch or compression of a factor of 1 divided by b. This h is a horizontal translation or a translation in the x direction. And lastly, the k value is a vertical translation or a translation in the y direction. So let's have a look at this first one here, y equals x to the 4. Okay, it's a quartic parent function, and let's apply these translations. So it wants to go 4 units left. Now remember, left or right is our h, that's our translation in the x direction or horizontal. It needs to be the opposite sign because the equation or the general form is negative h or minus h. So we have y equals, I'll leave a gap in case we need to put something at the front. Put an x, actually I should leave a gap there. Okay, just leaving a gap there in case we need to. So the opposite of left is right, so that would be positive 4. We know it's to the power of 4, so we've done the translation 4 units left. 6 units down, okay, that's k. K is our translation in the y direction, so minus 6. Reflected across the y-axis, that's here, that's this negative. So we have to put a negative in front of the x. Now there's no number to go there because it's a vertical stretch, and the vertical stretch or compression is out the front. So it's a vertical stretch by a factor of 4, so we simply put a 4 here, and that means we've done all of them. So we've got a vertical stretch by a factor of 4, reflected across the y-axis is here, 6 units down and 4 units to the left. Okay, let's look at the second one. We're going to do a cube this time, or a cubic. Doesn't matter, it still behaves the same way. So we're going to have y equals x cubed, but we need to add all these transformations. So first let's look at the horizontal compression factor of a half. Now the horizontal compression is here, and it's always a factor of 1 over b. So if it's told us it's already compressed by a factor of a half, that means our b value is actually 2. So it's going to be y equals, I'm going to leave a space again, I'm going to put 2x here. I'm going to leave a space in case we need to do a minus or a plus, and put my 3. So that's our horizontal compression. Okay, I'm going to have a look at the reflection across the x-axis now, which is here. And the reflection across the x-axis is just a negative out the front. Okay, and lastly, it's being translated 5 units to the right. So the translation is here in the horizontal direction. And remember, it's the opposite sign because of this negative. So if we want to go right, we're actually going to subtract 5 because a minus and a minus make a positive, which means we then go in the right direction. And that's how you apply transformations to equations of polynomials.